Hello, welcome back everyone. So let me quickly recall. In the last class, we saw the classification of crypto system. There are five different class of in which we can classify. The first one is based on your computer era. If we are having pre-computer era, the crypto system which are before invention of crypto computers or in use of crypto computers, that is called classical crypto system, and modern crypto system, that is post computer era. So you can simply say that early 20th century crypto system are classical, and after that is modern crypto system. So examples are Caesar cipher, Wigner cipher, Affine cipher, Hill cipher, and this one. And similarly, uh, if it is based on the encryption rule, that means suppose I'm having encryption key ek and decryption key dk. If both are same, then that is called symmetric key crypto system, or that is called secret key crypto system, skc. And if both encryption for encrypting and for decrypting both you are having different keys, then this is called public key crypto system. We call it as pkc also. These are some example. All classical crypto systems are your symmetric key one, and block cipher, stream cipher are some more example. And RSA, Gmal, AppSec, Rabin, these are your public key crypto system. Yeah. Next is block cipher versus stream cipher. It is on the basis of encryption process. In the block cipher, what happens, your message is divided into fixed size of block and then encrypted. Whereas in the case of stream cipher, it is all the messages are encrypted at the same time. So you can assume it as it is again a block cipher with only one block. And then deterministic versus randomized. In the case of deterministic, if you are having the message m, then the same ciphertext you will be getting, whereas in the case of randomized, if you are putting your message, say first time I'm getting this ciphertext, second time I'm getting this another ciphertext which is different from this. Okay, so that is randomized. That means output of the encryption root depends on some random number here. These are some example. And then pre-quantum crypto system and post-quantum crypto system. See, it is on the basis of strength of crypto system against quantum computer. If your crypto system is secure against quantum computer, that is called post-quantum, and if it is insecure, then it is called pre-quantum. Okay. Yeah, so now practically useful crypto systems. What do you this is practically useful see following two desired properties of a practically useful crypto system. The first property, it should be each encryption function and decryption function should be easily computable. Encryption function and decryption function should be easily computable. What do you mean by that? Suppose if you are having encryption rule, then you can easily encrypt your message. If you are having decryption rule, then you can easily decrypt your ciphertext. Correct? And the second property it should have, that is an opponent upon seeing the ciphertext should be unable to determine the key. That means after seeing the ciphertext, let me just write, an opponent upon seeing a ciphertext string y should be unable to determine key. Determine key or plaintext. These are the two practical, useful crypto system which we need to have. Okay. Now the process, the process of attempt to attempt to recover the key K or the message X or message X given a string of ciphertext, given a string of ciphertext is called cryptanalysis. That means the process of attempt to recover the key or the message by just looking at the ciphertext is called cryptanalysis. See, if the attacker can determine the secret key, then the crypto system is totally broken. There is no security at all if he is able to get the key. Thus, determine the key is at least as difficult as determine the plain text string X given the ciphertext string Y. Okay. One more thing. Sir Francis R. Bacon had proposed the following properties for good crypto system. Had proposed the following property for a good crypto system. What are the properties? The first one is, yeah, as we have already told you, the encryption function should be easily computable. Encryption should be easy. Second, decryption should be easy. That means if you are having decryption rule, you should be able to decrypt easily. Third is your ciphertext should not be much longer than plain text. Ciphertext should not be much longer than plain text. Fourth, yeah, just by looking at your ciphertext, you should not able to get the plain text. That's what we had already talked. If you are having ek of X, you should not able to get the message X from ciphertext. Getting message or key is difficult. Okay. Fifth is the avalanche effect. This is nice one. The avalanche effect should hold in crypto system. So what is the avalanche effect actually? Avalanche effect is an effect by which small changes in plain text or in the key, small changes in the plain text or in the key lead to big change in ciphertext. That means if you make small changes in plain text, your ciphertext is changed. A big amount of changes has been occurred in the ciphertext. Okay. So, for example, a change of one bit in the plain text usually result into changes in all the bits of the ciphertext. Okay. Yeah. And the sixth one, the crypto system should not be closed under composition. What do you mean by that? That means for any two keys, suppose I'm having key1 and k2, there should not exist a key k for any two key, say k1 and k2, there should not exist a key k such that this ek of w is actually ek1 of ek2 of w. That means it should not happen that suppose I'm having a message which I'm encrypting with the key k2 and then ciphertext I'm encrypting with k1, that can be decrypted just by a single key k. Should not happen. Okay. And one more thing is that seventh one, the set of keys should be very large. Set of keys should be very large. Okay. One more thing is that confusion and diffusion property which a crypto system should satisfy. Confusion and diffusion. What do you mean by confusion and diffusion? See, in 1949, Claude Shannon and there is one more and here. Claude Shannon in his fundamental paper presented the theory of secrecy and explain the by two properties, that is confusion and diffusion, that a good crypto system should satisfy in order to hinder statistical analysis. In order to hinder, yeah. The first one, let me just start with one by one. The first is confusion. What is this property? See, confusion implies that the key is not related in simple or direct way to the ciphertext. Key is not related in a simple or direct way to the ciphertext. Your key should not be depend directly in the ciphertext. So if the confusion is high, then an attacker cannot extract the information on the plain text from the distribution of ciphertext. Just while looking at the ciphertext, he cannot get any information on the key, so he cannot get anything on the plain text. The idea of confusion is to hide the relationship between plain text and key. In particular, each character of the ciphertext should depend on several part of keys. Each character of ciphertext should depend on several part of keys. So you can see that yeah, it is actually the idea is to hide the relationship between plain text and key. Okay, therefore confusion is high. Confusion is high if each bit of key has an influence on many bits of ciphertext. Has an influence on many bits of ciphertext. Okay, this is what confusion means. Next is diffusion. See, when change on a character of a plain text, when change on a character of the plain text yields change in all characters of ciphertext. Ciphertext and vice versa. Then it is called diffusion. So here, if you see, the idea is to hide the relationship between ciphertext and plain text. Okay, so the diffusion is high if each bit of a plain text has an influence on many bits of ciphertext. Okay, So if you observe in the case of confusion, uh, each bit of key has influence on many bit of ciphertext, whereas here each bit of plain text has an influence on many bits of ciphertext. So this is the uh, difference between confusion and diffusion. Okay, so Shannon says that if you want to have a good crypto system, you should have this property, confusion and diffusion. Key is not related in simple or direct way to the ciphertext. Each so here key and ciphertext, the main their notation that key and ciphertext the relationship is, whereas in the case of diffusion it is plain text and ciphertext. Okay, now the next section is cryptanalysis. Okay, maybe I'll do it in the next class. We'll do cryptanalysis, types of attack, and security notions. That will be the last of this chapter. Thank you.